These are the practice problems for lesson 7, all, some, or no solutions. And in problem number 1, you're supposed to decide if the equation is always true for any value of x, or if the equation is never true for any value of x. And so if it's always true, if the equation is always true for regardless of what value of x you choose, as I use the expression on each side of the equation for a separate linear equation, and I graph that, it's going to be on both sides. If it's always true, it's going to be the same line. It's going to have the same slope and the same y-intercept. It will be the same line. On the other hand, if there is no value of x that will make the equation true, so the equation is never true, it will have the same slope, but it will have a different y-intercept. So there'd be parallel lines as I look at one side, the expression on one side, and graph that as a linear equation. That will give me a line. On the other side, also a line, but those lines will be parallel. So in this activity, all of these problems, A through D, both sides will have the same slope, the same coefficient of x on both sides, because either they're the same line, which has the same slope, or they are parallel lines, which also have the same slope, but a different y-intercept. The third possibility is that there's only one solution for the equation, and so that would be lines with different slopes that intersect, and that doesn't happen in this problem. So this problem is only always true or never true. So let's just look at C as an example before we go into each of these problems. So the coefficient of x, which is the slope, which is m, is the slope. And in this case for C, do you see where that is 2 on both sides? So 2 times x is 2x here, and 5x minus this 3x, or plus a negative 3x, is also 2x. So the slope is going to be the same. So then is the y-intercept the same? Well, in this case, it's 2 times 3 is 6. In this case, you have the 6 right there to begin with. So the coefficient of x is the slope. In problem C, the slope is 2, so y equals 2x plus 6. So the slope is 2. For each unit of x, y is 2 times the value of x. And then 6 gets added. So that's what's happening out here. And we looked at these kinds of problems earlier on in the year, but it began with a value of 6, so you had to remember to add that value of 6 back. So anyway, the point is that you get the same equation on both sides, the same expression on both sides, so it's the same line. All right, so let's look at problem A. So they have the same slope. If I look at this expression and write a linear equation for this side and write a linear equation for this side, they have the same slope, slope of 1. But this crosses the y-axis at negative 13. This is x plus a negative 13. This crosses the y-axis at 1. So these are going to be parallel lines. They will never intersect, so there's no solution, so there's no value of x, which will be a solution to this equation. So if you work through it, if you figure out the value of x, you come up with something that doesn't make sense. Negative 13 does not equal a positive 1. So there's no value of x that I can find which will be a solution to this equation, because these two lines never intersect. They never share the same point. They never share the same pair of coordinates, the x value and a y value. B, same slope, 1x, 1x, but they have a different y-intercept. So this is 1x plus a positive 1/2, so it's going to cross the y-axis at a positive 1/2. This is going to cross the y-axis at a negative 1/2. So once again, there is no value of x that will make this equation true. So it has no solution. So you're going to get parallel lines. The y-intercept here is a positive 1/2. The y-intercept here is a negative 1/2. So this is y equals x plus 1/2. Y equals x plus a negative 1/2. So if you solve for x, you get something that doesn't make sense. You get 1/2 does not equal a negative 1/2. So if you look at the left side and compare that to the right side, They are different lines, but they have the same slope, and that slope is 1. The next one, can you see that? Oh, we already did C. We already looked at C. So this is 2 times x, and this is 2 times 3. And on this side, it's 5x plus, and I'm going to move this negative 3x over next to the 5x. So when I add them together, you end up with 2x plus 6 out here, plus 6 out here. So you get the same line. So as you solve for x, you get an answer that 6 equals 6, which is true. So what that means is that for every value of x that you choose, this equation will always be true because they're the same lines. Y equals 2x plus 6. So y equals 2x plus 6 is the same line. For D, this has a slope of 1, and this side has a slope of 1. Remember, the slope for all these 5 problems, the slope is always going to be the same, but this is 2x plus a negative 1x. It's going to be a slope of 1, and this is going to be plus a negative 3, and this is going to be plus a negative 3. So you just see, do you see that they're going to end up being the same line? As I separate this expression out and write a linear equation on this side and do the same thing on the right side, I'm going to end up with the same line. So it is true, always true, for any value of x you choose, this equation will be true. So work through, solve for x, you end up getting rid of the x's, and you end up with negative 3 equals negative 3. So the equation is true for all values of x because it is the same line. It's this line right here. Y is equal to x, so y has a slope of 1. So you go over 1 unit, up 1 unit, over 1 unit, up 1 unit. And this crosses the y-axis at negative 3, so right here. So it is the same line. It's always true. And the last problem, this is going to be 3x. The slope will be 3 because you multiply this 3 times this x, and it's going to be plus a negative 15. So this is a negative 5. 3 times negative 5 is negative 15. On this side, it's going to be 2x here, 2 times x, plus another x. So again, it has to have the same slope, 3x. But this is going to be plus a negative 10. 2 times negative 5 is negative 10. So these are going to be different expressions on each side. And so if I separate them out and write a linear equation for each, I'm going to get parallel lines. They have the same slope, but they cross this y-axis at different points. So as I work through this, I end up with 3x plus a negative 15, and this is going to be 3x plus negative 10. If I get rid of those 3x's, I end up with something that doesn't make sense. I end up with negative 15 that does not equal negative 10. So it says that there is no solution for this equation. There's no value of x that you can use to make this equation true. And what that means visually is that on each side, each expression, you have parallel lines. Y equals 3x plus negative 10 crosses the y-axis at negative 10 as a slope of 3. And y equals 3x plus negative 15 crosses the y-axis at negative 15 and also has a slope of 3. And so then when you make y 0, so if I make y 0, 3x is going to equal 15, x is going to equal 5. So if y is 0, x equals 5. This one, if y is 0, x is actually going to equal 3 1/3. And you might think about that. This is going to be 3x equals 10 because this negative 10 is going to go over here and be a positive when y is 0. So 3x will equal 10, x will equal 10/3. 10/3 is the same as 3 1/3. So they cross the x-axis at different places. Usually we don't talk about that. And they also have to cross the y-axis at different places. They have different y-intercepts. So y equals 3x plus negative 15, y equals 3x plus negative 10. Different lines, but they have the same slope. They will never intersect. There is no value of x that will make this equation true, so there's no solution. A solution would be when lines intersect. Either it's the same line, so every single point intersects, or they intersect at one point if it has a different slope. Problem number 2 says that May says that the equation 2x plus 2 equals x plus 1 has no solutions. There's no value of x that will make this equation true because the left-hand side is double the right-hand side. So this side is double what this side is. Do you agree with May? Explain your reasoning. Well, if you look at it right away, and if you look at each expression as a separate equation, you see that they have different slopes. This has a slope of 2. This has a slope of 1. So these two, if you draw a line for this side and draw a line for this side, or basically graph this side and graph this side, each has lines, those lines will intersect. This has a y-intercept of 2. This has a y-intercept of 1. So the first thing to do is just go through and solve for x. So if you solve for x, you're going to get x equals -1. So add a negative x here, add a negative x here to get rid of this x. Add -2 on this side to get rid of that 2. So this is a -2 on this side. And you end up with x equals -1. So now if we rewrite each expression in the form y equals mx plus b, so this is expression on the left side as well as the expression on the right side. Oh, first of all, let's check this by replacing x with -1. And if you work down each side, you'll find that you get 0 equals 0. That's going to become the y coordinate. So the x coordinate is going to be -1. The y coordinate is going to be 0 at the point that these two equations intersect. So if I write in an equation for the left side, y equals 2x plus 2, this right here, y equals 2x plus 2, the y-intercept is 2 and the slope is 2. So for every 1 unit of x, y is 2 times that length of x. So 1 unit over, 2 units up, 1 unit over, 2 units up. So y is always 2 times what the value of x is. And notice that it goes to the point -1, 0. So x is -1, -1, and y is 0. So right here, this y is 0. All right, so if I graph the right side, so I write a linear equation for the right side and graph it, I get y equals x plus 1. So this has a slope of 1, and it crosses the y-axis at 1. So it crosses the y-axis at 1, that's the y-intercept, and it has a slope of 1. So 1 over, 1 up, 1 over, 1 up. So what that means is the value of the change in the length of y is equal to the length of x. Say it differently. The length of y is equal to the length of x. For every unit x, y increases 1 unit, or is equal to 1 unit. I'm not saying that very well. Anyway, they intersect at this point right here, -1, 0. So x is -1, y is 0. So that's the one solution to this equation up here. So there is one solution to the equation. So no, I don't agree with May. This is the x coordinate of that point. That's the solution. So -1, and this is the y coordinate, 0. So you go over -1 and y is 0. So you have, if you write each side as separate equations, they have different slopes. So these lines will intersect at a single point, one point. That is the single solution to the equation. X equals -1, y equals 0. So y is the check. If you work down each side separately, you're going to get 0 equals 0. Or if you replace x with -1 in one equation, you're going to get y equals 0. And if you replace x with -1 in the other equation, you're also going to get y equals 0. It's the same as working down the left side separately from working down the right side. Problem number 3 is more of the same. So you have this equation, 1/2 times 6x minus 10, and that all of that minus x. And you're supposed to write the right side of this equation so that it is true for all values of x. And b is going to be to write the right side of the equation so it's not true for any values of x, so it's never true. So first of all values of x. So what that should mean to you by now is that you have the same expression on both sides. So you're going to get the same line. If I take this side and write a linear equation for that and graph it, I'm going to get the same line as if I took the right side and wrote a linear equation for that and graphed that. So what I'm going to do is just take this expression and rewrite the same expression, although in a different form. So if I simplify this expression, I'm going to rewrite this as adding the additive inverse. So the additive inverse of a positive 10 is negative 10, and the additive inverse of a positive x is negative x. So I'm just rewriting the same thing. So now I'm going to use the distributive property. So 1/2 of 6x plus 1/2 of negative 10. So you have to multiply 1/2 times this negative 10 here. And then to that, you're going to add negative x. So you simplify a little bit further. 1/2 of 6x is 3x. Plus 1/2 of negative 10 is negative 5. And then adding another negative x. So 3x plus negative x. I'm going to use the commutative property to move. Remember that this has a coefficient of 1 here. So it's a negative 1x. Negative 1x. So 3x plus negative 1x is 2x. You get 2x plus negative 5. So now if I take that equation right here, if I write this as an equation and graph it, this has a slope of 2. So the coefficient of x is 2, and it crosses the y-axis at negative 5. So right here at negative 5, and it has a slope of 2. So what that means is that for every unit of x, y is 2 units in length. So it goes over 1 up 2, over 1 up 2. So it's the change in y, or the length along the y-axis, over the length along the x-axis. The y-axis is always 2 times what the x-axis is, the length along the x-axis. So this is 1 unit, 2 units, 1 unit, 2 units. If I went 2 units, this would be 4 units, or 3 units, this would be 6 units. So the length along the y-axis is always twice the length along the x-axis. Y equals 2x, 2 times whatever the length of x is. And then you're going to add negative 5 to that. So it crosses the y-axis at negative 5. And so this expression on the left side equal to this expression on the right side. All the values of x will always make this equation true. Any value of x will make this equation true because it is the same line. Okay, now what happens if we change it so that there are no values of x that will make this equation true? So this is what we had before. So now if I just change the y-intercept of this line, so I just move this either up or down, but make it parallel, it will never intersect. There will never be a value of x that will make the equation true. So parallel lines means it has the same slope, which is the coefficient of x. It's going to have the same slope, but a different y-intercept. So I can choose any value out here that I want, and I'm going to get a parallel line. It's just going to cross this y-axis at a different place. So let's just choose 3. If you look at use 3, the y-intercept is 3, the slope is 2, so 2 units along the x-axis, twice that length along the y-axis, so 2 times 2 is 4 units along the y-axis. This is a parallel line. It has the same slope. They will never intersect. That's what parallel means. They'll never intersect. They will never share a coordinate, an x and y coordinate that is shared by each line. So there's no value of x that will make this equation, no value of x that will make this equation on the left equal to this equation on the right. So if you subtract 2x, get rid of the 2x on both sides, you end up with a negative 5 does not equal 3. This is problem number 4, which is more of the same. I think that these problems are easier for me to look at within the context of writing an equation for each expression on each side of this given equation. So you write an equation for 5 times x plus 2 and write a separate equation for 5x plus 10, and you're going to see that they're the same. So here's an equation that is true for all values of x because it's the same expression on both sides, which leads to the same line that's graphed for an equation of each side, which means that they are the same line. So all values of x are going to be true. So this is 5x plus 5 times 2 is 10, and this is 5x plus 10. Now Elena saw that this says that she can tell that this equation is also true for any value of x. So what is she doing? So she has to see that if she looks at an equation for each side, for each expression, she has to see that the slope is the same and the y-intercept is the same. So true for any value of x. So Elena keeps each side equal or balanced by multiplying by 4. So she multiplies 4 times 5, which gives her 20 right here, or she multiplies 4 times this whole thing, which is 4 times all of this, which eventually will be 20 right here. 4 times 5x is going to be 20x, and 20 times x is going to be 20x. So she keeps the sides balanced by multiplying by 4 and adding 31 to each side. So this side she added 31. So here's the 5x plus 2, and she added 31 right here. And this is 5x plus 10. It gets multiplied by 4, but she also added the 31 out here. So what happens then is 20 times 2 is 40. So 20 times 2 is 40. So this is 20x plus 20 times 2 is 40, and that 40 gets added to this 31. So that ends up being 20x plus 71. So 71 is the y-intercept. It's where this line, the graph of this equation on this left side, it's going to have a slope of 20 and a y-intercept of 71. On the right side, it's going to be the same thing. So 4 times 10 is 40, and that also gets added to 31. So 40 plus 31 is again 71. So she ends up with 20x plus 71, 20x plus 71. Now, I didn't graph this, but you can see this is going to be the same line. If I write a separate equation for each expression, it will be the same line. Slope is 20, and the y-intercept is 71. Same expression on each side, same linear equation on each side, y equals 20x plus 71. So for me, I can now visually see what's going on. For problem number 5, let's just solve this equation in the traditional or normal way that the authors expect without looking at equations right now, but just for each expression, but just looking at the whole equation using either Elena's first step or Lynn's first step. So they make different first steps to solve this equation. And so Elena, if you look at what Elena did, she got rid of the 1/2 x right here. So she just has 3 on the left side, and she has adding or subtracting 1/2 x on the right side. Now I added a negative 1/2 x, which is the same thing. So what Elena did is she started out with this equation, then she added a negative 1/2 x to both sides. That gets rid of this 1/2 x and makes it 0. You're left with 3, and now you have 7/2 x plus a negative 1/2 x plus 5. So she added the additive inverse or subtracted 1/2 x. They are the same thing. I just always like to use addition. I just think it's easier. Lynn, on the other hand, he decided to get rid of the fractions. So how do you get rid of the fractions? And notice that a hint here is that this 3 becomes 6. So 2 times 3 is 6, and this 5 right here becomes 10. So 2 times 5 is 10. So it looks like he multiplied through each term by 2. So 2 times 1/2 is 1. So this is 1x right here. 2 times 3 is 6. That's this 6. 2 times 7 halves is 7. These 2's cancel, you're left with this 7, so that's 7x right here, and 2 times 5 is 10. So he multiplied each term by 2. So now if we solve each equation separately, this is 3 equals 7 halves x plus a negative 1 half x plus 5, so that's this up here. The only difference is that I'm sorry, it's this right here. The only difference is that I'm calling this adding a negative 1 half x. So now if you combine the terms, 7 halves x plus a negative 1 half x is 6 halves x, and 6 halves is the same as 3, so this is 3x right here, and you're left with this 5. This 5 is added at the end for each step. So this is 3x plus 5, and so now if you solve for x, add a negative 5 to both sides. This is 3x now equals a negative 2. So 3 plus a negative 5 is negative 2. This 5 plus negative 5 disappears. That becomes 0. And to get rid of this coefficient, you multiply by the multiplicative inverse of 3, which is 1/3. You have 3 x's. You want to know what 1x is. So it's 1/3 of 3 x's. You also have to look at 1/3 of negative 2, which is 2/3. So 1/3 times negative 2 is a negative 2/3. So x equals negative 2/3. We should get the same thing on this side. And so we're here where Lynn multiplied through by 2 to get rid of the fractions. And I'm going to add a negative x, or Lynn can add a negative x to get rid of this x. So that adds a negative x on this side. So 7x plus a negative 1x is 6x. So now we have 6 equals 6x plus 10. And so now I want to get rid of this 10 on the right side by adding a negative 10. 6 plus a negative 10 is negative 4. And I'm going to multiply by the multiplicative inverse of 6, which is 1/6, to get rid of this coefficient. So I also have to look at 1/6 of negative 4. So that's a negative 4/6. So x equals negative 4/6, and negative 4/6 simplifies to, this is negative 4 right here, and this is 6 right here, and the 2's cancel, so you're left with a negative 2/3. So x equals negative 2/3 on the right side, x equals negative 2/3 on the left side. So now if we do go back and look at each of these equations separately, let's go back here for a second. So what I'm going to do is look at this equation right here, which is the same as this equation over here. And so I'm going to write them, just looking at anything, yeah, these are the beginning equations. So I'm going to write them each separately as equations for a line. I'm going to look at the graph of those lines. And where they intersect should be this solution, x equals a negative 2/3. So on the left side, y equals 1/2 x plus 3, y equals 1/2 x plus 3. And if I graph that, y equals 1/2 x plus 3, the slope is 1/2. So for every 1/2 unit of for every unit of x, y increases 1/2. So y is 1/2 the length of x. So that's what this slope means. So for each unit of x, each length of x, y increases 1/2 that length. So you go over 1 unit this way and up 1/2. 1 unit this way and up 1/2. 1 unit this way and up 1/2. And this crosses the y-axis at 3. So 1, 2, 3. So the y-intercept is 3. For the right side of this equation, the slope is 7/2. So one way to look at the slope of 7/2 is for every 2 units of x, y is going to be a length of 7 units. So y is 7/2 the length of x. So go over 2 units, 1, 2, go up 7 units, 1, 2, 3, 4, 5, 6, 7. Or go back 2 units, 1, 2, go down 7 units, 1, 2, 3, 4, 5, 6, 7. So this gets a little bit tricky to look at. Need a little bit more practice at fractional coefficients or fractional slopes. This is the same as saying for each unit x, you go over 1 unit of x. From here to here, you're going to go up 7 halves. So y will be 7 halves the length of x. So 1 unit of x, you're going to go up 7 halves. 1 half, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves. This takes some practice to look at that. But the point is the slope is 7 halves and the y-intercept is 5. So where do these two lines intersect? They intersect at x equals a negative 2/3, right here. And if you want to figure out what the y-coordinate is, you go back to either side and you replace x with a negative 2/3 right here. Work that out. You're going to see that this is a negative 1/3 plus 3, which is 2 2/3. On this side, negative 2/3 right here for this x. This is a negative 7/3. These twos cancel. You're left with negative 7/3 plus 5, which is a negative 2 1/3 plus 5. And that works out to be 2 2/3. If you check this, 2 plus 2 is 4. 2/3 plus 1/3 is 1 more. So that equals this 5 right here. So y equals 2 2/3 with either expression or either equation. And so this point right here is a negative 2/3, a positive 2 2/3. That is the solution for this equation. That's the one value of x that's shared at the same time. So the same y value, so the same coordinate between these two lines. It is where they cross, where they intersect. For problem number 6, you're given 3 equations to solve, and in each case you're supposed to check your solution. Turns out that checking your solution for this one is actually the hard part. So let's go through this. The first thing I always tend to do is change subtraction to addition by adding the additive inverse. So the additive inverse of a positive 6 is negative 6, so I'm going to add that additive inverse. The additive inverse of a positive 3x is a negative 3x. I'm going to add that additive inverse. And the additive inverse of a positive 8x is a negative 8x. So I'm going to add that additive inverse. So add the additive inverse, add the additive inverse, and add the additive inverse. It is doing the same thing. It's just changing everything to addition, which in my mind makes solving the problem or solving the equation much easier. So I'm just going to go through and use the distributive property. So 4 times 2, I wrote that right here. 4 times a negative 3. So it helps make sure that I'm writing down the proper sign of this term. So this is 4 times a negative 3x, which is a negative 12x. So down here you have 3x plus negative 6 equals 8 plus negative 12x plus negative 8x. You can combine these two terms right here. So that's a negative 20x, and I'm going to use the commutative property to move the negative 20x over here and the 8 over here, just so that it's in the same order as this side, so I can see things a little bit better. And I'm going to add a positive 20x to both sides. So I want to keep the x's positive if I can. If I do that, then it's going to be a positive 23x on this side, and I'm going to add, to get rid of the numbers, the integers, I'm going to add a positive 6 to this side, positive 6 over here, you get positive 14. And x equals 14 23rds. You have to multiply by the multiplicative inverse of 1/23. So you have to take 1/23 of these 23x's to get to 1x. That means you have to take 1/23 of 14, which is 14 23rds. All right, now that's a pretty tough fraction to work with, to go plug back into this equation and check your solution. So my suggestion is to, once you take x and take 14 23rds and replace x with 14 23rds, once you do that, do not do this multiplication. Just don't do it. Treat it as 14 23rds, 3 groups of 14 23rds, and see how far you can go without doing the multiplication, because eventually you're going to get to multiplying
so many 23rds, can't remember how many it is, times 23. So you're going to get rid of this denominator right here, 23 times, I guess it's 23 times 14 23rds. You get rid of this 23 in the denominator. So just be patient and let's take a look at what that looks like as you work through it. So I'm going to use the distributive property. So this is now a negative 12 times 14 23rds. So I have a negative 12 of these things. And I have another negative 8 of these things. You combine them together, you get a negative 20 of these things called 14 23rds. These are the same two lines on the last page. So now I have a negative 20, 14 23rds. And over here I have 3 14 23rds. I want to move these 3 14 23rds over to this side by adding a negative 3 times 14 23rds. I'm going to get rid of this term, and I'm going to add a negative 3 of these things over here. So now if I add them all together, I have a negative 20 of these things, and I have a negative 3 of these things. Add them together, you get a negative 23 14 23rds. So there you are. You're going to multiply negative 23 times 14 23rds. That's going to get rid of this 23 in the denominator. You're going to be left with negative 14. Negative 14 plus 8 is negative 6. That equals negative 6. Now I'm not going to go so far as to graph each side of this equation like I have been, but if I did, I'd get two lines. Let's go to right here. I'd get two lines. This line would have a slope of 3, and it would cross the y-axis at negative 6. This line would have a slope of negative 20. So for every unit x in length, y is a negative 20 units in length. It's a negative 20 times longer. It goes in the negative direction. And this would cross the y-axis at 8, and that point that these two lines would intersect. So this is a positive slope, so this is going from the lower left corner to the upper right corner. This would be a negative slope here, so the upper left corner to the lower right corner, they would intersect. Where would they intersect? They would intersect at 14 23rds. Then if you wanted to figure out the y value, you'd take that 14 23rds and replace x here with it, and you get a pretty tough number to calculate. You just work through it, and you get a pretty good idea from the graph what y is, but x is going to be 14 23rds. All right, the next problem. So I look at this, and the first thing I think of is to get rid of the 2 in the denominator, get rid of the halves. The way you do that is you multiply by 2. So multiply each term by 2. The mistake that some people will make is they will multiply only this term with 1/2 by 2 and maybe this 3/2 by 2. But you also have to multiply the 6 by 2, and multiplying 2 times 3/2. That's the same as if I had distributed this to 3/2 z and 3/2 times 6. I would then multiply both of those by 2. This is the same thing as multiplying 2 times 3/2 out here first. So I get z plus 12 equals 3 times z plus 6. So use the distributive property. You get 3z's plus 18. So now I want to get rid of this z right here. Add a negative z. That makes this 2z's. And get rid of this positive 18 right here. Add negative 18. And that makes this side equal to negative 6. And then I have to look at 1/2 of 2z's. So I have 2z's multiplied by the multiplicative inverse, which is 1/2. That tells me what 1z is, and 1z is 1/2 of negative 6, which is negative 3. So you take the negative 3, replace z up here with that negative 3. 1/2 times negative 3 plus 6 equals 3/2 times negative 3 plus 6. So this is negative 3/2 plus 6, and this is 3/2 times 3. 6 plus negative 3 is 3. So now I have a negative 3/2 plus 6 and a 3/2 times 3. Well, 3/2 times 3 is 9/2. And I chose to make this 6 12 halves, so I could add it to the negative 3 halves. I could have just called this a negative 1.5 and added that to 6. That would be 5, and then another negative half. That would be 4.5. Could have done it that way, which is the same as 9 halves, by the way, which is 4 1/2. A couple ways to do it. So you end up, in my case, I ended up with 9 halves equals 9 halves. And the last problem, again, I'm going to change this to adding the additive inverse, which is a negative 7w. So 9 plus a negative 7w equals 8w plus 8. And I want to keep the w's positive, so I'm going to add a positive 7w to this side so that these remain positive. I'm going to add that positive 7w here. So I'm going to get 15 w's right here plus 8. And over here I'm left with 9. And I'm going to add a negative 8 to both sides. This goes to 1. And I had to multiply by the multiplicative inverse of 15, which is 1/15. And so 1/15 of 1 is 1/15. Now to check this, I'm going to replace the w with 1/15. Now I could have chosen to just treat this as a negative 7 times these things, these 1/15, and then added a positive 7 times 1/15. I would have gotten a positive 15 times 1/15 on this side, because 8 plus this 7 would be 15, and this would go to 1. So it'd be 1 plus 9, 1 plus 8 would equal 9, and you'd be left with 9 on this side. Instead, I chose to, it's a pretty easy fraction to work with, so I chose to just multiply by the fraction. So this is a negative 7/15. This is a positive 8/15. Add 7/15 to this side. This goes away. Add 7/15 to this side. This becomes 15/15. 7/15 plus 8/15 is 15/15. So 1 plus 8 is 9. So 9 equals 9. So in this case, because the fraction wasn't too bad, I multiplied. Or I could have done what I did in the first problem in this set and just left this at 1/15 and worked with it. Eventually, I would have gotten 15 times 1/15, or 1 right here, and that 1 plus 8 would then equal 9. So take a look, think through both ways. For problem number 7, you're given a point that's on a line with a slope of 4, and you're asked to find 2 more points on the same line and then write an equation for that line. So if I graph this point, it's at negative 3, 6. So that point's right here. So it's negative 3, 1, 2, 3, positive 6 for y. And so that ends up right here. And then the slope of 4 means that for every unit in the x along the x-axis, the length along the y-axis is 4 times that length along the x-axis. So 1 unit, this goes up 4. If it's 2 units, this goes up 8. If it's 3 units, this goes up 12. So if I just start here and count 1, 4, so up 4, over 1, up 4, over 1, up 4. So that's a slope of 4. And up here you notice that it crosses the y-axis at 18. Y equals 18 when x is 0. So you can use that to write the equation. That is the y-intercept. So you have m, the slope, and you have b, the y-intercept. So y equals mx plus b. Here's the slope, by the way. So for 1 unit along the x-axis, it's 4 units along the y-axis. So that's 4 over 1 equals a slope of 4. So the slope is 4. So y equals 4x plus b, slope of 4 right here. And b, we figured out, is 18. So the equation is y equals 4x plus 18. Now that's the pretty straightforward way of doing this problem. But you don't want to always do it That way you want to do the problem that shows that you have more depth in your thinking of how to solve these. So let's do this the second way. Let's use a slope triangle. So we're going to end up with y equals 4x plus 18. What we're going to do is if we start here and go to this point, then we want to figure out the length along the x-axis and figure out the length along the y-axis by subtracting the beginning point. That's going to place this point at the origin. This is the idea of using a slope triangle to figure out these lengths, and also using this relationship to figure out the y's and the x's. So no matter what I choose along this line, I have to subtract 6 units to slide this down to the x-axis. And I also have to subtract these -3 units, which by the way is the same as adding 3, to slide this triangle over to here. So that when I do that, so here 14 minus 6, I'm going to take away the starting point of 6. 14 minus 6 is equal to 8, so that tells me that this length is 8 units. And this length is this -1 minus -3, so it's adding 3. So -1 minus the -3 equals 2. So this length is 2 units. So once you slide this triangle down here, the coordinates of this triangle tells you the lengths. That's why we do this. So this coordinate is 2 along the x-axis and 8 along the y-axis. So this length is 2, this length is 8. So then I can figure out the slope. It's 8 divided by 2. This length is 4 times longer than this length. So 8 divided by 2 gives you a slope of 4. They already told you that. This just confirms that calculating the slope in this way, it works. It confirms what they tell you. Now to figure out what the y and the x, how y and x fit into this equation, remember that you subtracted 6, so y minus 6, which is the same as y plus a -6, and you added 3, so x plus 3, which is the same as x minus a -3. So this tells you that the length along the x-axis, x plus +3, whatever that length is, the length along the y-axis, y plus -6, is going to be 4 times this length along the x-axis because the slope is 4. So what that tells you is that this length along the y-axis is 4 times this length right here along the x-axis. So this length along the y-axis, which is y plus -6, that's this length right here, whatever it is, wherever you choose this point, it's going to be y minus 6 or y plus -6. That's going to be always 4 times longer than this length along the x-axis. Wherever you are, you're going to figure out this length along the x-axis as taking this x coordinate and subtracting where you started. So you're going to add +3 or subtract -3. So y plus -6 equals 4 times x plus 3. Use the distributive property, so now there's the slope that shows up, 4x, but now you have 12 out here, but you need to get to 18. Well, this difference, this is always going to make up the difference to equal what this y-intercept is. So in this case, you add a -6, so you have to add a +6 to get rid of this, and you add a +6 here. So 12 plus +6 equals that 18, which is the same 18 as up here. So you get the same equation. You have to get the same equation. Y equals 4x plus 18. Up here, y equals 4x plus 18. So again, this takes a lot of thinking, but the more you think about it, the more you understand the movement of the slope triangle and what you are doing to calculate these lengths, the better understanding of this part of mathematics you'll have. So think through it, practice it,